Right, well, Chris and I are going to be looking at light bulbs today, so we're moving on from watches. So this is something that sort of come up as a modeling example in the stately Discord. We've been talking about it, Chris and some others as well, and it's one of these seemingly simple problems that is deceptively nuanced. So we thought it was actually worth walking through some of the options, ways to model it, and maybe why some models might be preferred over others.
Yeah. In the future we'll have to move on to like less physical modeling of physical entities and more software, but um,
Yeah,
for some reason the physical things we love to model. I don't know why. um, yeah. So um, this came up because a while back, Parker Codes, who on the Stately Discord, like asked this question of, has anyone tried to model an and state? So basically, the there's two switches on a wall and there's three light bulbs. Um, and when you turn switch one on, um, it turns on light bulb one. When you turn off switch one, it turns off light bulb one. Same for switch two and light bulb two, right? So they're connected together. And then the last light bulb is only turns on when both lights or switches are on. Um, that's sort of the domain that we're trying to model here. Um, and yeah, as Fraser was sort of saying, there's actually like a couple different approaches that you can model it, and they all have their own um, benefits and trade-offs. So that's what we're going to dive into. um,
yeah, and it's probably worth saying, and this came up in our discussions, is that it's sort of a question like, do you look at whether the switches are on or whether the lights are on to determine what state light three is in? And we've sort of just said that we're just imagining that the switches are sort of not in our model and they're just sending events to our model, so we just receive toggle, toggle light one, toggle light two events, and then our system has to do with that what it will. There's sort of another discussion there around sort of the domain modeling, a bit of reverse engineering that we might get to another time.
yeah,
But that's just to simplify and just focus more on the modeling discussion, I think.
yeah. So we have a close. We've already determined what the closed system is. Are you able to see my screen?
Let me see.
We could always.
Got it.
Cool.
Gotcha.
Um, okay, so we have four different approaches that I think we've identified, and obviously, there's probably a couple more out there. So if you do think of another one, let us know. Would be interested to think about it. Um, this is probably like the quote unquote simplest approach, which is sort of to enumerate all the possible states that we can be in, using only finite set of states. So there's no hierarchy or orthogonality. Um, if I'm just gonna zoom in a little bit, um, it are oops, thought I could make that smaller. We have four states. We have a state where all the lights are off. We have a state where only light two is on. We have a state where only light one is on. And we have a state where all the lights are on, including light three. So light one, two, and three are on. Um, and as you toggle the light switch, we could sort of simulate this. So if we turn on light two is now on. We turn on light one. Now all three lights turn on. Um, we turn off light two, then only light one is on, and yeah, if we turn off light one, then all the lights are off. So that's this approach. Do you have a name for this, Fraser? Like enumeration?
I just call it enumeration. I guess we have another one similar to this. I guess the distinctive thing about this is that sort of the state of each switch isn't necessarily explicit. It's sort of tied up in the logic of determining if light 3 is on. You're saying, well, light 1 must be off at this point, but you're not really explicitly saying that at every stage. So
Right.
there's not a piece like an orthogonal piece of state that's just keeping an eye on light 1, which is kind of interesting. And maybe we can talk about later about how that might play out or model and why or why not you might want to do that. But otherwise, maybe we just go through sort of briefly the other ones and
Sure.
come back to
Trade-offs
the
later.
details.
Perfect. This is approach number 2. That really gets at this concept of derivation. The fact is like if we model each light in an orthogonal manner, in a parallel manner, right? So light 1 is its own sort of entity, light 2 is its own sort of entity. Um, Light 3 derives its state from those other two states. And we'll get on the trade-offs later, but that's exactly what's happening here. So we could turn on and off light 1, it doesn't affect anything. We could turn on and off light 2, doesn't affect anything. But when both lights are on, then light 3 turns on. And the way this works is these transitions in light 3 as part of SCXML are called eventless transitions. I think a better name for them are immediate transitions. They're happening immediately all the time on any possible change to this particular machine. And we have a card here that says always check when any change happens whether both lights are on. And if that condition is true, if that case is true, then turn on. And same thing for turning off. Yeah, that's sort of how it works. Anything to add, Fraser?
Not really. This is the only one out of the four that uses guards. Or sort of, it's basically inspecting the state of the model as it is, rather than being raised events. I think we can actually categorize sort of two types of approaches as sort of raising events and inspecting the state within guards. I think there's a couple of trade-offs, so we can dive into that once we get through the other examples.
Yep. Yeah. What do you want to explain this one?
So this example is sort of half enumerating, I'd say. So the light 3 is listening to events that are raised from light 1 and 2. So light 1 gets a toggle switch 1 event, but then it raises a switch on event. The light 3 is basically saying, I don't care which light is on, I just need to know that one light is on, because then if another light comes on, then it only should be on. So sort of saving half of the enumeration because it's saying I don't really care which light is on. So if you click through, then you'll sort of see that behavior.
Yeah, and the important thing here is there's still like a derivation that's happening, but it's happening instead of happening through introspection like we just saw, it's happening through broadcast, internal broadcast.
Yeah.
Then that's what like raising events here means. So we'll dive into trade-offs of that, but I think we have one more approach outlined here. Let me just reset everything. This is very similar to the previous one, except the only thing that's different is we're not raising events. Light 3 is actually just listening to external events. So if we turn on switch 1, light 3 is not on yet, right? It's not in an on state, but we are keeping track of whether light 1 is on in light 3. Same thing for light 2. So we turn off light 1. We are keeping track as part of light 3 whether light 2 is on or not.
it's sort of a combination of the first approach, which is enumerating all the states,
Mm-hmm.
and then the third approach, which is you still keep the orthogonal components for the other lights.
Yep. Yeah. So those are our four approach. Those are the four approaches that we came up with. Um, so yeah, let's dive into the trade-offs. I think you're gonna be most opinionated, or to my knowledge, you're most opinionated about this one. Um,
Uh, well, yeah, let's look at this. So I guess enumeration, firstly, it becomes a bit explosive. So if actually, let's talk about because we're going to talk about these models and designs, and we're going to basically probably going to be saying what's good and what's not, and sort of what is our justification for that? And I think it's Martin Fowler who said this, and you've got two designs that meet the current requirement. Better design is the one that most easily can be changed to your requirements.
mm,
That's one way of sort of thinking about design, and one way I like to evaluate a design is just come up with some ways you might change the requirements and see how you have to change the model if you even can to adapt to that. So an obvious way you could do this is say, well, what if there's a third light? Oh, sorry, there's a third light, and then the fourth one will be sort of and of all of them. But
right.
there's another light that it needs to track. And with this approach, you'll need nine states, I think. It's a cross product, right? So it's three by three.
Yep.
You've got three lights. You'll need nine states. Keep track of all those lights. Um, and similarly, if you had another light, it would be 16. So that's a pretty big downside, I would say, of this approach.
Yeah,
Um,
and it's not just states; it's also transitions because you now on almost every single one of these states you're gonna have an additional transition for that switch being toggled too. Um, I know we usually talk about state explosion, uh, but one of the interesting things is also transition explosion, where there's just a multitude more of events that you have to listen to. Um,
yeah,
in fact, what's really funny is that state charts actually add more states and they typically reduce the number of transitions,
right.
which is weird because we usually talk about how state charts help state explosion, but it's not. It is the case, but it's also like not the case. There is also like if we look at this, we have um, one, two, three, four, five. We have nine, or we have nine states, right? Compared to
Mm.
four, but we have a lot less
Yeah,
transitions.
mm. That's a good point. Um, yeah, not something I've actually thought about before. And Rails, a lot of Rails discussion is actually on the edges or transition, um, to minimize those. But if we look at the two, the first, I think it's the first and the last that both do enumeration. It's still a question of what's the trade-off between explicitly having these orthogonal
Mm-hmm.
components for the lights or just having it all in one. One thing I can think of is that if you had some behavior that always happened to the lights, then you're going to have to duplicate all those actions in within each of these states.
Mm-hmm.
So if toggling, I don't know, if you toggle something in the light and then it has to do some other action, and if you've got an orthogonal component, you can just put that there and it will run all the time. Whereas you're actually going to have
Right.
to enumerate over all those behaviors as well. Um, and then you'd also, if you were having a UI sort of reading this model, you'd have to derive what lights were on or off from these states rather than just being able to look at the orthogonal region,
Mm-hmm.
which might not be too bad, to be fair, but that is something you would have to do. Um, there's also, I think, the other sort of having the orthogonal components seems a more natural way of evolving the design. If you imagine you started with two lights and then you added the requirement of the third light.
Right.
Because you haven't really had to change the structure too much of the other lights. Whereas with the just enumerating and then not having orthogonal components, you actually basically have to reconstruct all the state every change.
Mm-hmm.
I didn't even think about doing that, which is interesting in itself. I always lean towards having the parallel components of the lights,
Yep.
sort of having.
It.
But I didn't even think you could. I guess you could do that, but I don't know. Do you have anything to say?
Um. I find it really like the concept of parallel states is, or orthogonal states is sort of decoupling things, right? That's really what we're doing here.
Mm.
All lights are on is really this coupling between the fact that all three lights are on, right?
Mm.
Same with these other two, with these other ones, right? That's where that like state explosion is coming from. Uh, and it's not. I gravitate towards or like this type of model where at least where like how we derive the third state is not necessarily like not what I'm talking about, but just the fact that all three lights are orthogonal from each other in some respect, but also might have
Mm.
a dependency on each other. It you can understand the flow a lot quicker, I think, at scale, right? If we had a fourth light bulb, really easy to understand what's happening here. Um, because and that's like one of those things that I if I go on Twitter quickly, uh, that's one of the benefits that I think this picture is what I was looking for. Which one's easier to follow the flow of? And I know this is just like a hypothetical state chart, but like this is really hard to follow, right? And at
Totally.
least with the state chart, we have this, we could sort of determine the flow of like, okay, we can go from B to C. Oh, and on some transition N, we actually leave the state Y and we can never go back to it, right? It like, there, like, it just, I feel like the orthogonality and hierarchy describe the flow that we're trying to do better than an enumeration of finite states. I think that's also interesting to me too.
Totally. There's still something I think maybe it's not so important because I probably wouldn't go for the either of the enumeration options, but it's kind of my tendency is usually if there's an entity like a light bulb, it tends towards being orthogonal.
Yep.
Right, but there's something interesting in sort of implicitly having the first one's almost more like how you would just do the logic of an and in a state chart.
Yep.
So there's something interesting about that, but I'm not sure if I have more to say on it now, but something to think about. It's more like if you just said, what does an and mean? That's sort of what an and means enumerated in all states. Whereas the fourth one or the other approaches sort of are thinking about something else as well by keeping track of the other lights.
Yep.
Um,
That yeah, I don't know. There's just something easier to reason about the orthogonality of it. I don't know,
yeah,
and how it deals with change.
yeah. Should
Um,
we have a look at the third one?
yeah, sure.
'Cause this is sort of tries to reduce maybe the enumeration aspect of it.
Mm-hmm.
Um, at the cost of you don't really light three doesn't really know which light is on, which the requirements it doesn't say it has to.
Right.
I just wonder if there's something in there where if you change some of the requirements, it might break down a little. I'm trying to think of what that might be. Um, if I don't know if you added a third light is not on and the other two are on. I just wonder whether you'd struggle to implicitly track all that.
Like
What are we,
maybe like maybe for some reason the requirements change and light 3 is actually located like really close to light 1, and you actually want to
Mm.
put it on some kind of dim when light 1 is on,
Yes.
but not light 2. Some
Yeah. Yeah.
theoretical, but like what that's highlighting is there in the future there could be a requirement that has some dependency between light 1 and light 3.
Yeah.
Um, that requires you to know that that requires light 3 to know that light 1 is on.
Yeah. I
Yeah.
agree with that.
And I think you nailed it on the head. I think we both like orthogonality, but I think for that's the trade-off for this particular case. Light 3 is like more decoupled, but it also, maybe that's a bad thing.
Yeah. I'm not sure convinced that it's sort of a halfway house between enumerating and not. And
Yeah.
it sort of relies on the fact that if it gets to switch on events, it knows it can be on. But I just wonder whether that assumption or that way of deriving the state could be a bit brittle to some
Mm-hmm.
requirements. If you had additional light bulbs, for example, that some were on and some were off, you might end up sort of a weird enumeration where you're sort of trying to shortcut all the states, but it's actually less clear.
Yeah.
Um,
I I also worry about raising. You could already see
mm,
here if light 2 and light 1 change at all, like let's say there's more transitions, it's likely that you were going to have to raise in more locations.
that's a good point. If you had a third light,
Mm-hmm.
you'd that would need to raise, wouldn't it? So the raise becomes a way to look at it was if you had light one and light two, and then you added this requirement that there's a third light and it's an and you
Yep.
actually have to change code in light one and light two to make this work because of the way we're raising.
Yep.
Um, so the change isn't encapsulated in the new requirement. It sort of leaks into the existing structure of the state chart. It's sort of the trade-off with raising is you have to do that, I think.
Yeah.
Compared compared to the second one, which is Vanguards, which we didn't have to change anything about Light 1 and Light 2 to add this requirement, which I think is really nice.
Yep.
Um, the dependency almost goes one way. Light 3 needs to know about Light 1 and Light 2, um, but the others don't know anything. There's a little bit of nuance there because it's a fairly loose coupling between lights because you're raising events. I'm not really quite sure how to think about that
It,
because the benefit of using events is not really coupled, and it's sort of the argument against in guards is sort of that now there's these states that if you change them, other parts can break.
yep.
I think there's a really interesting discussion here, and I've swung full circle on this.
Yep.
Not full
We were
circle,
both very against
180
Ingards.
degrees. I've
Sorry.
I've been against Ingards, been
Same.
an Ingard hater, but I've actually I think they're actually quite good.
Um,
And actually, my pick of the four options is definitely number two. I don't know about you.
that I've been leaning to number 2 for a while now. Maybe one perspective to think about this is push versus pull reactivity.
Okay.
Um, which is something I'm not the most knowledgeable about, but this concept of like raise like when light in this particular model where we're raising events, um I could be remembering push first pull reactivity wrong, but like we're sort of pushing out we're pushing out events from light 1 and light 2 so light 3 can react to it, right? Whereas here with an immediate transition, and in guards were like sort of pulling in those changes into light 3.
Yeah.
I like maybe that highlights the difference in approach.
Oh, and you can see if we add that requirement that there's a third light that you need to end, the changes are all, apart from adding in that component as an orthogonal component,
Mm-hmm.
the changes are all in the guards that relate to light 3. I
Yeah.
think it's quite a nicely like co-located change. Whereas, as we said, with raising, we're actually having to add that raise into, and it just the flow is actually a little more challenging to follow. I think, like if you say the requirement is that if light 1 and light 2 are on, then light 3 should be on. The in-guard actually reads exactly like that. I think that's another nice property about it, is that if you just said those requirements out loud, that's how the state chart reads.
Right. That's a good point. Yeah.
Maybe we should talk about why we initially weren't so thrilled about in-guards. It's quite interesting that we've both sort of maybe changed our minds. And it's sort of, as there are arguments against guards, I'd say.
Um, the, the I feel like for me in guards. So the thing about state charts is once you add hierarchy and orthogonality, um, you want to be very careful about breaking refinement. Maybe that's how I think I used to think about it, right? Like we have these hierarchies, and we do want to keep these hierarchies as decoupled as we can. So one way to approach that is to not transition deeply into a hierarchy. Another one is to not transition out of a deeply out of a hierarchy. Um, right, like modeling with that approach helps keep things decoupled. Um, and in the same vein, I feel like in guards always broke that encapsulation that you would get. Um, I think they almost always show up with parallel states too. That's the other observation. Um, and
Yeah,
the goal of parallel states is to keep them as decoupled together. And so I feel like we always, or at least I always thought about like raising events in like is like how, like events sort of a better decoupling. And I think the at least for me what's changed is uh it's like the coupling lives somewhere, right? And these are just different like in guard the coupling lives in the state that's being derived. With raising, the coupling lives in the everything else. um and I think that's what's changed is I think I see the combination of like immediate transitions and in guards as a way to derive state, um, which is historically like something state charts are really bad at. I feel like compared to approaches like functional reactive programming, where like you try to maximize derivation of everything. Um, State charts take the other approach. It's like be as explicit as possible and don't derive everything. And I like as a result, I feel like deriving state in the state chart has always been troublesome until I think you helped me realize that this combination that we're looking at right now is actually like probably the closest we can get to like deriving a state uh, in a state machine, like in the model, like the model deriving something of itself.
yeah, it's sort of
That's
like introspection in the model.
yeah,
What, and that's you raise a good point about the dependency or the coupling is somewhere. I think the original attraction to events was partly you could imagine having two orthogonal regions,
Mm-hmm.
and then if you're listening to events, you could just move one of those regions into another actor, and then you send events from the actor. You don't have to change the other region because it was only listening to events anyway.
Right.
Whereas if there was an in-guard if there was an in-guard between those two regions, and then suddenly that region disappeared, it breaks the state that or the region that was trying to inspect the state. That's sort of the coupling or the bit of fragility that you introduce, is that there's an assumption that the state exists,
Yep.
and I think the problem is that what you want is you want to know what state the other region is in. That's what is the problem. So in a way, trying to skirt around that with events is more indirect. It can lead to something we haven't quite mentioned is if you're going to use events and not in guards, you actually have to duplicate state
Yep.
in the region. So all those event-based ones have some sort of duplication where we already knew that light one was on, but light three has to store that somewhere itself.
Yep.
Um, you end up with this sort of duplication problem. Um, whereas what's wrong with actually just explicitly saying, yeah, there's some relationship between these parallel states. It's sort of where I've got to, and
Yep.
part of it was my issue with guards needing to know the structure of the state chart was if you're using sort of a path-based ID, that's very brittle.
Yep.
So if your ID is, state state one on active, and you have to go through that whole path, then if any one of those changes, then your ID breaks. Um, so that sort of is not really nice, but I think I've realized that that's actually a problem with the ID and how the ID is being generated, not with cards themselves. If you've just got a way of saying, I want to know about this particular state, and you might have a manual ID, or you might have another way of doing an ID. It's just tied to that state, and it doesn't change if things around it are changing. I think that's actually really quite nice.
Yep.
And you mentioned that visually, these sorts of things like are actually a bit error, and it's part of it is sort of the textual format. If you want to just target a state, you're aligned to it visually, but and then if you move that around, it doesn't really change where your line goes to. The ID in a text format becomes a bit trickier.
Yep.
Um,
And just to clarify what you were saying about um, the ID being different than a state path, Harrell does that in his Citizens Watch, right, with these in guards, which
yeah.
is we can we can say like alarm one is disabled and only when D is pressed when we're in alarm one dot on, and that doesn't take in to that doesn't factor in the entire rest of the state chart. Um, like the hierarchy of the state chart, it's just this state with like a
Sort of
very
the
unique ID.
minimal unique path
Yeah,
sort of thing. It's like if you've got a unique state, then just use that, or else add to the path until you've got a unique ID,
exactly.
which very often is very concise and pretty resilient to change, I'd say.
Yep.
Um,
Um.
sort of, sort of this idea like it's not that raising events decouples it totally, right? Because we're relying on those states to raise those events.
Right.
So if you got rid of that, your region would still break. It's arguably less coupled. It's not a total like solution to the coupling issue, which is why I think for the other benefits you get, you don't have to duplicate states. So on, I
Right.
think
And
Vanguards are probably more of a trade-off I'd make.
yep. And I think one of the interesting things here is that's why I'm not the biggest fan of this last model that we went through, where we are just duplicating all the state in an attempt to completely decouple these regions. Um,
Yeah.
And what you lose here is you lose that derivation that we're trying to be very explicit about. When it, like because you look at this, our requirement is that light 3 should only be on when both lights are on. You have to walk through this entire model to figure that out. Whereas here, it's explicit, very explicit in the model that like light 3 it can only be on when both lights are on. And here you literally have to like simulate the model in your mind to figure out to translate this particular model back to the requirement. Um,
Really.
which is why I'm not the biggest fan of this approach.
There's also the fact that in guards, when they break very explicitly. It's clear why. Whereas if you have sort of this raised event or event chain that you're relying on to be correct, if you deleted that raised event so it wasn't being raised, in a big system, it actually could be a bit unclear what's going wrong.
Mm-hmm.
And that's the advantage of making it explicit that you are looking at the state and
Yep.
saying, I want to know what state this is in, because then when that breaks, you go, oh, well, the state doesn't exist anymore. I need to fix this path or change something. I think there is something to be said for being explicit in what you're doing, which is you're checking what state is in, and then having that
Mm-hmm.
break, uh, really breaking fast and clear. You have opportunities for diagnostic errors to tell you what's going on.
Right. Yep. Yeah. Exactly. Like in that case, like the interpreter engine should just error, well, hopefully error out, um, being like, hey, this ID to this state isn't a valid thing. Which
So,
is actually a really good point. I never thought about it like that before. Um,
might be interested. So there's a section in Horrocks' book, uh, which is his sort of design heuristics, and one of them is keep dependencies out of independent concurrent parts. It's sort of
mm,
exactly what we've just been talking about. And he sort of comes to a different conclusion. Um, and some of the reasons he gives for not using in guards is that it makes testing more difficult because you can't run the parallel regions independently anymore. Um, it's harder to maintain because changing one part might cause an unwanted effect on another part, which is sort of what we discussed. Um, and then so he sort of talks about this merging the concurrent parts
mm-hmm.
rather than having in guards. But then he sort of caveats that by saying that if you have lots of states that need to be merged, you could have the state explosion. So you need to consider that carefully. Um, I think we sort of talked about the maintainability or the coupling. I'm interested in the testing side of it. Do you have any thoughts on that?
Um, I I mean I I personally you don't like or like the way I think about it, you don't like test a specific like I'm never gonna be like okay I'm gonna just test light one, right? Like the machine is the if we're talking about unit testing, the machine is the unit. Um, if you really want to isolate an orthogonal state, then you put it in your its own machine and spawn or invoke it. Um, that's sort of
Which
my take.
I guess it does limit splitting like that, doesn't it? If you've got in guards. Um,
Oh, that's a good point, actually.
like what I was saying was that actually, if you've got in guards between regions, you can't split them.
Yeah. Okay. That's actually a really good
It's
point.
it's an interesting uh, yeah, it's an interesting factor. I'm sort of with you. I wouldn't. There's maybe a deeper question about testing in unit tests, but I don't. I'm not really sure how you'd go about testing a parallel state in isolation anyway. Um,
Right.
you'd still be relying if you're raising, you would still be relying on the other regions raising those events, unless you're going to create some sort of test fixture which fires those events in, which you might do. But you actually have the similar problem with context if you're
Yep.
testing sort of scenarios, you can have parallel regions modifying context in ways that you rely on to. You'd have to be mocking context potentially, and in
Mm-hmm.
the end, you have this mocking issue where you've mocked everything and you're not testing anything that's actually part of your system, just about.
Yeah.
So I'm not a testing expert, but so there might be other opinions on this, but just personally, I'm not convinced by the testing argument.
Yep.
I think I'm much more convinced by having a clearer machine and one that's easier to change. And I think Oric sort of implies this when he says, if you have more states, this approach might not work. Um, and maybe he's just made a different trade-off, which is fine, totally fine. But I'm not so convinced by some of those things. And maybe I used to be more convinced about that.
Now it's funny. I feel like the past month, we've both gone down the same route.
Yeah. So I think, yeah, for us, the second option within guards is the winner.
Yep.
Um, but yeah, I'd be really interested to hear what other people think about this. And they might have stronger opinions on in guards and testing and that sort of thing.
Yeah. And I think it. I think the really interesting thing about this example is the derivation that happens. Um, that's really what these different approaches are trying to do with the tools that we have provided by the state chart. Um, you know,
Really.
a valid another valid model is to derive light three outside of the machine. In some, you know, like
Yeah,
I could totally see someone saying that. Like
totally.
funny
So
enough, it ends up being
yeah,
similar to these in guards, but
similar, I guess. So we've talked about this. So we were thinking about how in data modeling, one idea is that you should keep the minimal amount of date and then derive the rest.
mm-hmm.
If you had first name and last name, you wouldn't keep full name in your state. You would just derive that as combining your first and last name.
Yep.
And so that the thought as well, maybe light three is similar to that, where it's a derivation of light one and light two. So does it even belong in your sort of core model? Um,
Yeah.
so I think what I've come to think about this is that I don't think that light three is a derivation in the same way that full name is a derivation, because derivation in the data modeling sense sort of implies you're not adding new information because you can already derive it. It's sort of just a
Mm,
combination, or it's a view of the existing data. Whereas when you add light three into the state chart, you're actually adding new rules about what can and can't be, that do not exist before. So you don't know that light three is able to make these transitions and be in these states unless it's included in your model. It's You can derive light three being on in these conditions as much as you can derive light 1000 being on,
mm,
if that makes sense. And until it's in your model as a rule, it's not it doesn't exist as something that you can just say is from light one and light two. What do you think about that?
I I definitely see where you're coming from. It sort of gets to the thing we avoided in the beginning, which is like, what are the boundaries on the model? Maybe like if light three exists and we're sort of not including it explicitly in the model, then is the model wrong? I don't know.
Yeah, I don't
I
know.
I
I mean,
sorry.
I think there's sort of, I guess the main point is I don't think derivations in data modeling is necessarily the same as deriving finite state. But I guess you could say, well, if you just wanted the UI for light three, you could derive that.
Mm-hmm.
from light 1 and light 2 and just turn light 3 on. So maybe it comes down to you need that behavior. Like, does light 3 have a behavior? Because if it does, you sort of need it in the core model because it needs to react to events. Otherwise, you sort of would have this. If you had lots of derived states, you'd still need to forward events to them and then back because they
Right.
might be participating in the event handling.
Yeah. Oh,
Maybe the maybe maybe the more of it is just like does light 3 have behavior?
right. And um, is it important enough to make explicit too? Someone can look at this machine, like let's say we just commented out light three. Someone could look at this machine and just think there's two lights, but there's really three. The other one exists somewhere else. So there's also this. There's also like this co-location of behavior that's happening.
Hmm.
Um, yeah.
Yeah, I don't know that maybe that's just some extra thoughts. I'm not part of it. It does get confusing when you have a physical system. I think. Um, but maybe yeah, maybe we'll have to get onto a proper app.
Yeah,
Hmm.
definitely. Cool. Any last thoughts, or are good to feel good about this?
Pretty good. I'm most interested in what people think about in guards.
Yeah.
Because that's something I've sort of recently changed my mind on.
Mm-hmm. Same. Yeah. No, I'm interested as well. Cool. Well, thanks for watching, everyone. We'll see you next time. I'm not sure we know what we'll do yet, but it'll be fun. Maybe we'll. I think the thing is when we did the Citizens Watch, we sort of remodeled something that already existed, and then today we sort of said, assume these models exist. What are the trade-offs between them? So maybe next time we'll do like a from the ground modeling of something. Um, I think that would be fun.
Yeah, sounds good.
Awesome. All right. Till next time.